In this next video, we talk about the Chapman-Kolmogorov equations under discrete Markov chains. Chapman-Kolmogorov equations. The Chapman-Kolmogorov equations are fundamental results in the study of Markov processes. They describe how transition probabilities evolve over multiple steps. They allow us to compute long-term transition probabilities from short-term ones. So we already know the Markov property that so for a stochastic process, Xn is called the Markov process if P of Xn plus 1 equals J, given that Xn equals I, comma, Xn minus 1, all the way down to X naught, is simply equal to probability of Xn plus 1 equals J, such that, given that Xn is I, that's the probability of moving from I to J, a probability that given probability of J, given that you're coming from other states, simply reduces to probability of moving to J, given that Xn is already I. So everything before it doesn't matter. So this means the future depends only on the present state, not the past. And that is why we have it called a memoryless situation. So transition probabilities now which we saw in the last video. So define Pij in n steps to be equal to probability of Xn equals J, given that X naught equals I. So that means if you start coming from I, you will end up at J after n steps. So this represents the probability of moving from state I to J in n steps. So talking about the Chapman-Kolmogorov equation, then we say that for any integers mn which is greater than or equal to 0, the summation Pij of m plus n, so those n is the same thing as the m and n, right, added together. So it's the summation over k of Pik in m steps, probability of moving from I to k in m steps, multiplied by probability of moving from k to j in n steps. This expresses multi-step transitions in terms of shorter transitions. So the interpretation is that you go from state I to j in m plus n steps. So you move from I to k and then k to j. That means move from I to k in m steps, then move from k to j in n steps. That means you're moving from I to j overall in m plus n steps. So go from I to some intermediate state k in m steps, then go from k to j in n steps, sum over all possible intermediate steps k. That's the idea of the Chapman-Kolmogorov equation. In matrix form, we say that let P be the transition matrix, then P in n steps is equal to P, the matrix P raised power n. So the Chapman-Kolmogorov equation then becomes that P raised power n plus n is equal to P raised power m multiplied by P raised power n. And that feels like the law of indices, right? So we have the two-state Markov chain. So for the transition matrix P, which is 0.7, 0.3, 0.4, 0.6, to compute P squared, now we compute P squared, which is P dot P. That means like I like to do that, 0.7, 0.3. I think that was done in a previous video, right? So that's basically okay, I feel like I should still do it. 0.7, 0.3. So we have P to be 0.7, 0.3, 0.4, 0.6, right? Um okay, so we have that. Then we just want to take a square of this. So P squared will have to be 0.7, 0.3, 0.4, 0.6 multiplied by 0.7, 0.3, 0.4, 0.6, so that P squared now is equal to, so because we have two rows here, you write each column twice. So that's 0.7, 0.4, 0.7, 0.4, and 0.3, 0.6, 0.3, 0.6. So that is, then we put this over the first row, 0.7, 0.3, 0.7, 0.3. Then the other one, 0.4, down there, 0.4, 0.6, 0.4, 0.6. So that P squared would now be 0.7 times 0.7, that's 0.49 plus 0.12. Then this is 0.28 plus 0.24. This is 0.21 plus 0.18. Then down here we have 0.12 plus 0.36. So overall, we have P squared to be, this is 0.61 up here, and this is 0.39 here. Then here we have 0.52, and this is 0.48, right? So you see, if you add this and this, you get 1. If you add this and this, you also get 1. So that's P squared right there. That's how to do that. So if you square P, that's what we get. Now, yeah, so that's exactly what we have right here. So to now verify that, of course, that's P1. So probability of moving from 1 to 2 in 2 steps is summation over k of P1k in 1 step and PK2. So you move from 1 to k in 1 step and from k to 2 in 2 steps. That means P11 times P12 plus P12 times P22. And that results in 0.39. Okay? 0.39. So this matches the matrix results, you see. To move from 1 to 2 in 2 steps. So you have this here. So you move from 1 to 1 to from 1 to P11 to P12, and then so in 2 steps, so you end up getting 0.39, which is this particular value here right now. So we can also simulate that and we get that matrix like that. Then you can also, of course, for the check-in, right? You can also do the check-in thing, and you get all this. So if you say M in 2 steps, N in 3 steps, and then you keep moving like that. So probability M plus N, we give you this. Then if you now do probability M multiplied by probability P power M multiplied by P power N, it gives exactly the same. So they are equal. So that is true. So you can verify the Chapman Kolmogorov check. So the summary of Chapman Kolmogorov is that P raised power M plus N is equal to P raised power M times P raised power N. And that is what has been verified here using Python code. So we talk about the continuous time Chapman-Kolmogorov equation. For continuous time processes, Pijt plus S is equal to summation over K of Pik of T, Pkj of S. So this is the continuous analog of the discrete time equation. The intuition here is that if you think of breaking a journey from A to C in 5 steps, so you can first go from A to B in 2 steps and then from B to C in 3 steps, then sum over all possible intermediate states and you get what you need to get. So that's the kind of idea we have here. So you have a kind of 3-step thing. So you have this P matrix and you're in 5 steps, you get this result. If you add, this is roughly 0.25 plus 0.425 plus 47, 25 plus 47. That is 82, then 82 and 28. So is that 82? No, that should be 72. 72 plus 28 is roughly 1, like that. So just to be sure that each row adds up to 1. Then we talk about interpretation of entries now. So entry Pij in n steps represents probability that xn is equal to j, given that x naught is equal to I. So example, uh, what's the probability that you move from state 1 to 3 in 5 steps? That's probability of going from state 1 to 3 in 5 steps. That's Pi3 in bracket 5 up there. So the key takeaways from here is that the Chapman-Kolmogorov describes how probabilities compose, and then multi-step transitions are computed via matrix multiplication. It is fundamental to Markov chain theory, and it enables long-term predictions. So some common mistakes when we talk about the Chapman-Kolmogorov equations, forgetting to sum over all intermediate states. So because it's like you're breaking a journey, so you have to add up every intermediate state. Then mixing up matrix multiplication order, that can be a problem. Then assuming independence instead of conditional dependence. So we have some practice problems. Given P to be this, compute P2. We have done that before. For the same matrix, find P12 using Chapman-Kolmogorov. Okay, now maybe that will now make me try to do that. Yeah. So we have 0.8, 0.2, 0.8, 0.5. I think that's easier to memorize. 0.8, 0.5, right? 0.8, 0.5. Okay. So P is 0.8, 0.2, 0.5, 0.5. And then we're looking for, we need P2, and then we need P12 in two steps. Okay. So this is what we do. So for P2, of course, this is P2. P2 will be 0.8, 0.2, 0.5, 0.5 multiplied by 0.8, 0.2, 0.5, 0.5. So then that is, because we have two rows here, you write each column here twice. That's 0.8, 0.5, 0.8, 0.5, 0.2, 0.5, 0.2, 0.5. So then you put this over it. This is 0.8, 0.2 here, 0.8, 0.2, 0.8, 0.2. Then 0.5, 0.5 also comes down here as 0.5, 0.5, 0.5, 0.5. So that we then have this to be P2 now is equal to 0.8, 0.8, that's 0.64 plus 0.10. This 0.5 times 0.2. Then here you have 0.16 plus 0.10. Down here we have 0.40 plus 0.25. Then here we have 0.10 plus 0.25. So that we have P2 equals 0.64 plus 0.1, that's 0.74, 0.26 here. If you add that, and here you have 0.65, and this is 0.35. Check. This plus this, is it 1? Yes. This plus this, is it 1? Yes. So that's a way to check that what you have done is correct. So that's that. Interestingly, we can actually find P. mm, So interestingly, we can find the other thing we need to find is P12 in two steps, right? Since you have found P2, so P12 in two steps will just be this, because this is 1, this is 2, this is 1, this is 2. So 1 to 2, it's just this 0.26, 0.26. So the harder we would have been to find P12 multiplied by, multiplied by P12, right? Multiplied by P12, that multiplied by P22, right? Plus P11 multiplied by P12. Because here what I'm trying to do is 2 cancels 2, 1 cancels 1. So you still have your P12 in two steps. So this is what would have got, right? But maybe let me do that, right? But what I'm trying to say is that first of all, you can read, since you have got P2 already, you can just read P12 off from there straight and you get your results. But if you want to go the harder way, the longer route, so you have 0.8, 0.5, right? So now we are saying to find P12 in two steps, which we could have easily read off from here, 0.26. Let's confirm that. So to find that, we know that is P12 in two steps is simply P12 multiplied by P22, yeah, because 2 cancels 2 and we get 1, 2. Then plus P11 multiplied by P12. 1 cancels and we still get our P12. So just put all this together and sum up. Okay, so let's go. Oh, okay, I thought I was going to write the matrix. P is 0.8, 0.2, 0.8, 0.2, 0.5, 0.5. So now we have, this is P12, right? So we can fix it up. P12, this is 1, this is 2, this is 1, this is 2. P12, that is 0.2. So you have 0.2 here. P22 is 0.5, this. So we have 0.5 plus P11. P11 is 0.8, this. So that's 0.8, 0.8. P12. P12 is 0. Yeah, P12 is still 0.2. So now we have 0.10 plus 0.16, and that is still 0.26, like what we would have easily read off from here, 0.26, same. Yeah, so that's how that works. Now we have so question 1 and 2 done. So I'll just leave you to take care of the rest. So we have P1, given this, compute P3, we could do that. So it means P3 is P1 times P2. So that goes. Then 5, given a state chain, a three-state chain like this, compute P2. I mean, that would just be more tasking. You just square, just follow the steps. It's just that you have more numbers to deal with. From problem 5, compute P13 to using the summation formula. So, well, even if you don't use the summation formula, once you square this, you can just read off 1, 3 and you're good to go. You get the result there. But since you're told to use the summation formula is what I just finished doing. That P1, 2, 2 thing, like that you do P11, 1, 2, and all of that. So show that PMN is this for M equals N and N is 2. So try that. Then you want to try this to compute, square that, verify Chapman Kolmogorov for one entry of problem 10. That works. Then 12, if P12 is all this and all this and all this, compute P13. Of course, P13 is just going to be P, because you have three things here now. I'm tempted to do this. Yeah, this looks tempting to do. Let me just go for it. I need to snip. Let me snip this and go for it. Um, so I get a new one. So I copy that and go back here. So we need P13 in 2 steps. So P13, let me go this color now. So P13 in 2 steps here will just be, so like we did before, this will be P13. So you're looking for something, 3 will have to cancel if you start with this. So P13 multiplied by P33, so that at the end of the day, you still have your 13. Then plus, you now need to do P, we have done P13. So we can still do, okay, there's 1, 2, 2, 3. Okay, well, we'll go with what we have, right? So you have P13. Let's go with what we have. So this will be P12 multiplied by P, we are looking for 13. That will be P23. Okay, 2 cancels 2, so we get 13 already. The next thing, we have P23. Oh no, we can't use P23 here because we need 13. So P23 cannot work here. So but P13 can work. So P13 multiplied by P, because we need 13. So that will be P31. There's no P3, there's no 31. All right. 2, 3 won't work. 2, 3 won't work. We have P1, 1, 2, 3. So 1, 3, there's no 3, 1. So that doesn't hold again. So we can use P13 itself. There's no 3, 1. Yeah, so I think this is the best we can do, actually. So for P13 in 2 steps now. So we're not able to, so we have 1, 3. So P13, the closest part to it is 1 to multiply by 2, 3. So because this cancels, we get 1, 3. But normally, if we are going to use P23, we would need P. Okay, we couldn't even use that because the starting point is not that. So we could have used P13 multiplied by P33, but we don't have three threes because this would have cancelled. But so this like what all we have, you know, is like all we have, and then so okay, let me just clean this off and keep going. So that's like P12, that's 0.4 multiplied by P23, that's 0.5. And that is simply 0.20. And that's it. Yeah, that's what we can do with that one. So explain why the sum over all k is necessary in Chapman Kolmogorov. Yeah, because it's like we are breaking our journey, so we have to sum up every intermediate point. So given this, find P5. That's a long one. Show that each row of Pn sums to 1. Of course, that's how you know you have done the correct thing. Then, given a transition matrix, explain how to compute P10 efficiently. So you have to probably break it down, like do P2 and keep doing it like that. If P2 is known, how can you compute P4? Yeah, if you know P2, just multiply P2 by P2 and you get P4. So yeah, you have the rest of this. And given all this, write explicitly for a three-stage system. So that means K is 3 now. So then for N, for a two-stage system, derive a general expression for Pn and all that. So yeah, try your hands on all this. Let's see how helpful, how well you get the gist, actually. So let me know how helpful this is for you. If there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, why not? Go ahead right now, hit the subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join. That gives you special privileges like getting to see some videos first, being the only one seeing some videos, hanging out with me online or physically to discuss whatever interests you on this channel. You can also um you can also ask for PDF copies of my notes. Ultimately, don't forget to comment, like, and share so that other people can get to see the great content I have going on here. Till I come your way again, keep doing maths right. Bye.